Up, up, up. From my nose to the teeth to the tip of the tongue. Okay, so what do I want to talk about? Well, what did we talk about last time? Where did we leave off? Anything? Did we talk about anything? Were we even here? Were we present? Was I present? I'm sorry? Pointers, sure, that was a big part of it. And again, pointers being a very big component to the language. And then after pointers, what do we talk about? Dereferencing. Yeah, so that's an operation we can do with pointers to go to the memory location specified at the address within a pointer. What else? Well, what sort of addresses to what can pointers store? Dynamic arrays, as Yoda would say. Yeah, so we can dynamically allocate stuff, right? Things in memory. Well, we'll talk more about what I mean when I say this certain aspect of memory. So the operating system gives us this memory, returns an address. What command does that operation I just described? New. And so the new command goes to the operating system, requests some number of bytes, and gives us the address to that memory location. Okay. Anything else? I'm just trying to stall here because I'm just trying to open this USB. Because I'm pretty sure that's pretty much it in broad strokes. I mean, there are details. I'm hoping that you guys go through lecture slides and examine those details because the questions on the exam won't be, what did we talk about? Please open. Okay, so it is recording. All right, so I don't need this. But I do. You know, I'm just going to have to grab it from the interwebs. Bum, 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 bum. Bum, 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 bum. Oh, I see. That's unfortunate. Okay. Download this. Okay, and so dynamically allocated memory. So I mentioned the words. You don't have to understand it, but so when you use the new command, the operating system grabs the memory, and it grabs it from a location that we coined it as the heap. It's unfortunate because we will be using the term heap for something else later on, but there is a memory location we call the heap. That's where the new command grabs its memory from. Now, the only thing of note with regards to this thing called a heap is that the memory that is allocated from that location does not follow the same scoping rules as everything else we've seen so far. That is to say, if we declare a local variable within our program, that's declared in what we call the stack. All right, we call that the program stack. And whenever any of those variables declared in that way go out of scope, what happens? Yeah, they go away. So all local variables declared within your program go away. Anything that you allocate using a new command do not go away. They remain persistent till the end of time, or until the program ends, or until you do what? You delete it, right? That is to say, the delete command deletes the thing at the address stored in that pointer. Does that make sense? We'll see plenty of example code, but that's the thing to keep in mind, that it does not go away following the same scoping rules that we've seen with regular variables. And that leads to many, many complications with the code that you write, in particular memory leaks. That's the big one that you'll see, and we'll talk about that in some detail. And then everything about today's lecture is pretty much how this idea of these dynamically allocated variables remaining persistent, what is the consequence of that in the programs we write, and how do we manage that through our program? And so I want to make sure I have the proper, there we go. Okay, but before that, I want to sort of review / discuss a minor point. Okay, so if you see this declaration, I'm just going to do this now. And so if I wanted you to translate that, what would you say? What would be the English discussion point for this particular line of code? What am I doing? Yep. A lot of words. I like them all. So I'm declaring an integer x, or if I do it from right to left, x is a integer, right? And so what? So what if I do something like this? Can someone describe to me this line of code? Yeah, so that's discussing the functional aspect of what this is. But if I wanted to literally translate this line of code, I could go from right to left and say that p is a pointer to int, right? Which functionally stores an address of integers. Okay. Okay, and so now using that line of thinking, someone describe to me this. Yeah, so p2 is a pointer to int. And so, well, regardless of, so let me do it one more time just to kind of be silly. Or not so silly, because you will see this. And so p3 is a pointer to int. All three of these store what kind of things? Addresses is just a little bit different in terms of the address of what type of thing. And so so we know that this indicates that this stores an address to int, as MJ indicated. And so this thing stores an address to what? To a thing that stores an address, in particular an address of integers. And so p2 stores addresses of integer pointers. Okay, there's another way of phrasing what we were just saying. And so p3 stores an address of a thing that stores an address to integers. Okay, and so that's to say p3, well, p1 can point to what? Things I already have existing in this particular world, p would point to whom if I wanted to point to anything? X, because x is an integer, points to integers. p2 could point to whom? p1, because p1 is an integer pointer. And then p3, p2, right? Because p3 can point to integer double pointers, which is what we see here. Okay? And so all three of them store addresses, but addresses of a certain type, right? So I can't have p3 point directly to x, because x is not a integer double pointer. Okay? So just bear that in mind. And so there's a couple exercises that talk about this idea and how you go through doing certain things with regards to this stuff. In particular, this is something that is very useful. Then we get rid of p3. Then we get rid of this parentheses because it's artificial. Well, we know that I can dynamically allocate what to p1. Well, an integer. I can have a point to an integer memory location, right? I can have, if I do something like p equals new int, say 4. Can someone reason out what this line is doing? Let me get rid of some of this other marks. Well, okay, so what is this doing? It might be new to you, but what do you think it's doing? Creating an integer with what initial value? 4. That's exactly what it's doing, right? So the parentheses, it's almost like a constructor for integers, even though it's not. It's just initializing this memory location to 4. And so if I want to visualize this, right? And so, yes, when I declare p, let me go ahead and just create some memory for these guys. So, well, for just p alone, so say p resides here. It has its own memory address because it's just a variable. Let's say it's at address xaa. When I do the new command, it goes to the heap, or the operating system goes to the heap, says, okay, so I want to allocate an integer, so it's this size number of bytes. I want to fill there the value 4. This has the address 0xabb. And then what does this assignment do? I'm sorry?
Where's new memory?
Uh,
Are you talking about p equals, or are you talking about new?
oh, I'm sorry. So the new command did this,
Yeah.
but then it does something else in conjunction with this assignment operator.
Look, is it the address?
Yeah, so what should I put here?
0xbb.
Yeah, BB. And so this is what it'll look like if you want more graphs. You could imagine it having an arrow pointing to this part of the memory, right? And so this is part of the heap. This is part of the stack. Again, you don't really need to know that. Just a way to visualize these things. Okay, that's great. And so now, suppose then I wanted to have P2 manipulate this value. Say I want to change this memory location, the value here to say 6. That's my goal. But I don't want to use P to do it. I want to use P2 to do it. So what do I need to do first? Let me go ahead and create P2's memory. So here's P2. Right now it's garbage values because I didn't initialize it. All right. And so let me clean this up. Let me move the stuff down. So first line of code was P equals new int 4. And so now I want to have P2 say it resides in 0xAF. And so I want to use P2 to change this memory location. Well, I need to establish a relationship between P2 and this memory location, right? How do I establish that relationship? Yeah, I can have it refer to P, which P already has a relationship with this memory location, right? And so how do I do that? What would be the line of code? Well, I'm making some sort of assignment at the very least.
You point it to the value held within p. You point p2 to the value held within p. To the address held within p.
So you're suggesting to have 0xbb here?
Uh,
So what address? So they just take a look at just do it in terms of pictures, right? So what address
the
can I?
reference value of p. Okay, now.
OXAA. You guys see that? Because what type of thing does P point to? Address to integer pointers. This is an integer pointer. What is its address? 0xAA. Right. So this is what I want. And so now that this has the address 0xAA, I can dereference this address to go here to access this memory location. And so now I'm currently looking at this memory location. How do I get here? I mean, I can't just refer to this and do something here because this is just an address. I need to do something to get to here. I need to dereference again to go to this memory location. And now I can do something, anything I want here in terms of manipulating it. Okay, so we just described, we look at the picture and we describe in words the operations we want to have happen. So we now need to translate that. And so how do I translate P2 point to P1? That's a pseudocode. What's the syntax? P2 is equal to the ampersand. That's my ampersand. P, just P, right? And my black is dying. Be black. Okay, let me redraw this because new marker. That's a semicolon. Okay, let me make an actual attempt. I'm sorry, I shouldn't be this. Yeah. Okay, so anyone disagree with the syntax? Okay, no complaints, we'll run with it. I don't know, I'm not a compiler. So you can run it on your own and see if it works. So presumably this will get the address of P1, assign it to P2, and so it seems like that's reasonable, right? That will put this address into here. Okay, so now that we have this, we want to first go to, without writing a whole paragraph. So we want to go to P and then go to, the address stored in P. Yeah, so it's without stating it. So I want the dereference P2 to go to P, then dereference that to go to this memory location and change that to 6. Do I need to write that out, that comment, that pseudocode? So I said the word dereference at least how many times? Twice. And so what are the symbols? What is the syntax for dereference? Asterisk. And so not one asterisk, but with 2 asterisks, and then the thing I'm dereferencing twice is whom? P2. All right, because P2 stores the first pointer address. We dereference once to go here, dereference twice to go here, and now that we're here, what can we do? If I want to make it 6. Yeah, equals 6, boom. That's the syntax. Okay, and so that's how you deal with n pointers or multiple pointers, or how you can in terms of indirectly manipulating items. Right, so that's one application. Okay, pretty clear. You'll see exercises on it. Or pretty clear. I'm like asserting that it's clear to you now, as if it would be true. So, is it clear enough for you to reason about these sort of problems if you see them? Okay, so please do. You will see them. Okay, so that's one application. And so another application is to, well, no, I think that's enough. I made it more complicated than I needed to. So that's my blurb on multi-pointers. In particular, for these double pointers, you will see that, well, you saw it before. For those who look deeply into Project One code, what did I do there with something that looked like this? Something with the world. So what was the world? What was the context of this thing called world within that program? What was its role?
State of one world compared to the state of another world.
Yeah, that's a bit more meta than I need. Well, so what sort of object was it? How were we manipulating it? Just one of them, not both of them. How was I handling it? What sort of symbols were being used in conjunction with this world or other world? Yeah, square brackets. Do you guys see the square brackets there? Which is like an array, or a 2D array in particular. If you look carefully through the loops, it looks like I was looping through a 2-dimensional array. If you don't know 2-dimensional arrays, you might want to look into that. And so you can, for this particular thing, I can allocate what they call a 2-level array. Just some words. You don't have to. It's not for this class. This, I would test you on this in, say, CS52. Right? For this, if I wanted to use this to point to dynamically allocated arrays or 2-dimensional arrays, in the context of dynamically allocated memory, they're actually called, in this case, 2-level arrays. Right? And I won't go into details here. I might put up a video as to why that is. 2-dimensional arrays are different, right? Versus 2D, right? So versus 2D arrays. Which, for the 2D arrays, may I erase this here? You're answering for everyone? I'm going to assume so. I'm sorry, I always do that. One brave voice, got to smash it down so they don't revolt. Okay, and so 2-level arrays, essentially, you should have saw code that looks something like, so P2 equals new something, 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 but then P2 sub something equals new something else, right? So there's 2 levels of newing going on. I don't want to go into details because that's part of the homework. And so you saw this, and so I created a 2-level array. But notice I'm allocating something here and allocating, again, something here. Each time you see a new command, that's a new memory location, and you have no guarantees about where those are. Okay, you remember that about dynamic allocation? So the addresses returned by new, you have no guarantees about where they are. In particular, this new command may not be anywhere near the address for this new command. All right, and that has some huge implications about the performance of your code. As opposed to 2D arrays, so if I declare, say, int r, and I do something like this. Well, it's kind of a pain, so let me just do this. I'm not going to initialize it, or more than 1 dimension, so 2. What am I doing here?
Creating a 2x3 array.
Yeah, 2 by 2 rows, 3 columns. But the thing is, while we visualize this as if it was, it looked like this, we would pretend that it looked like this, right? In our minds, and we would try to access this using the 0th row and the 1th column, right? Is this intuitive, or is this unfamiliar to anyone? Okay, so this is clear. I might put up a video up on dimensional arrays versus 2-level arrays. I haven't decided yet. But it turns out the way this is arranged in C++ in memory is that everything is next to each other. This is actually what it looks like in memory. Is there any other seats anywhere? If not, Jacqueline, you can sit on any other desk. It's up to you. Oh yeah. So I mean, this is something to keep in mind, right? This is why 2D arrays are so much faster than two-level arrays, or even any other data structures that we talk about, right? Because it's this contiguous behavior, contiguous formatting of memory. Anyways, just background. We'll come back to this later. But again, so when you go out there and you post on the Stack Exchange or Reddit forums, there is a distinction between what's called a two-level array, which happens when you're dealing with pointers or dynamically allocated memory, versus 2D arrays, which is what you do with compile time arrays. Okay? And this has nothing to do with this class. It's just background information. It is important, because it seems like people haven't encountered these concepts. And so, again, I want to test you on this, but the background information is useful because it gives you intuition on some of the things that we will be talking about. Anyways, enough of that. Okay, and so let's talk about actual data structure, not data, C++ dynamic memory stuff. And so we stopped off talking about what happens if you don't have enough memory, and I believe this is where we are. Okay, any questions so far? I know it wasn't really, not a lot of meat here, but I just want to introduce some concepts to you. Okay. Well, yeah. We'll have to train you, let you know which lights to turn on and off, right? So, but then I have to pay you, otherwise there'd be union issues. Okie dokie. So, using new and delete in a class. Okay, so how might we incorporate these new commands into our programs? So suppose we have this class, the PyNerd, and it seems like we have a default constructor in which I go through a for loop, and, well, m sub pi looks like it's currently a integer array with 10 elements. That seem reasonable? Or is that a correct interpretation of what we see here? Yep. Yes, thank you. And so what am I doing here? Assuming, well, what do you think this is doing? You said it, but I don't know if the people in back heard you. What do you think this function is doing? Just take a guess. Assuming names mean something. Yeah, it seems like I get the jth digit of pi and assigning and putting it into this jth location of the array. I like it. And I'm doing this for how many digits? 10, right? Because I'm doing this 10 times, and assuming this doesn't do anything to break the loop, which any reasonable implementation of this, whatever this is, should not break it. And then I can go ahead and show off if I'm a PyNerd. Okay, and so that's great, but not very useful, right? So this assumes that we only deal with 10 digits. So we want to change this so that we can memorize as many digits as we can, not just 10, right? Make it a little bit more robust. And so, first of all, we don't want to limit ourselves with just 10 memory locations to store 10 digits. And so we want something a little bit more flexible, and that would be to do what? I'm sorry? What kind of variable? No, I am hard of hearing, so don't think your answer is wrong. I just can't hear. Dynamic, I like it. And so what does that imply with regards to syntax? A pointer, right? And so I can change this to a pointer. You're correct, dynamic. I like it, boom. Très bien. And what do you think this m sub n is doing for us? Yeah, size. So typically when you deal with arrays, even compile time arrays, you have to keep around some variable that keeps track of its size in some form, right? It's just a fact of life. And so typically you have these guys, you have two guys, one which will point to the array in the heap or whatever is being dynamically allocated, and then you have something that indicates how much you actually requested or have available to you to play with. Okay, so now we have this. We no longer have the integer array or the compile time array, and so we need to make some changes to the rest of the code to allow for this new flexibility. And so what happens if we change our constructor to indicate when we declare a new nerd, we let the compiler know how many digits this particular nerd is capable of memorizing. So that's the change. And now the question is, what do I do after that? So I pass in a number, say 10. If I wanted to keep the same number of digits. If I pass in 100, what can I do with that 100? If the idea is to allow this pi nerd to remember 100 digits of pi. Yeah, allocate enough memory to store 100 digits. And so what would be the syntax for that in this convenience space? Well, when you hear dynamic allocation, you think the keyword. So new certainly has to appear somewhere here. And then what follows, what would be on the right-hand side of new? All right. The type. And so the type of things that we're trying to store are what? Well, what's the type of, well, integers. We need to take a look at that. So we need the new command. We need the type of thing that we want. And so, but what else? No, we don't just want one thing. We want how many things? N things, or lowercase n. So how do I make an n array of integers? Square brackets, n, and then semicolon. Those are square brackets. I know they don't look like it. OK, but this isn't quite it. And so this will request this amount of memory from the operating system. The operating system will give it to us. This will return a, or rather more directly an address in which we can store that into what? A pointer. And so how would I complete this line of code to do what we want, given what we have here? Yeah, going right to left equals to m sub. Who is it? M sub pi. Sorry. And then if you're Spanish and upside down, semicolon there. So, not really. Please don't. No, there's no such thing. Sorry, just being a bit silly today. Not enough sleep. So, let's go ahead and do it. Pop. And then, of course, we need to remember the fact that this is how many digits we have in that dynamic allocated array. OK, now what? What else do I need to change? The whom? The loop. So what in the loop? So this goes how many times currently? 10. I want it to go how many times? N. And so this changes to? Boom. Boom. Or m sub n. I mean, in this case, assuming that these two remain consistent for this entire function, which it does, you could use n as well. But they're both the same, right? OK, and then also here. Boom. OK, so now we have a pi nerd that can be as smart or, well, I mean, it's not. Knowing a million digits of pi doesn't necessarily mean you're smart. It just means you know a million digits of pi. I mean, not to put them down. That's amazing. Great at parties. So anyways, boom. And then we also need this, right? If you want to allocate dynamic memory within your class, you ought to have, or you really, really, really should have, a destructor that cleans up that dynamically allocated memory. And since m sub pi is an array, or a dynamically allocated array, we have to use these square brackets to indicate that we want to delete an array at this address. OK? Question or just stretching? Yeah.
So when we're doing that, we don't need to dereference mpi before we set one of the digits to the space.
Oh, you do. If I want to actually change the memory location, I always need to dereference the address. And so the issue is, or the question ought to be, am I dereferencing anywhere here? The answer is yes. It turns out the square brackets does dereferencing. All right. And so go back to the previous portion of these slides. They talk about in some detail, but they discuss it there. Or they meaning us last week. OK, and then here we can go ahead and declare a couple nerdy students. not so nerdy 5, 3.14159, so I'm moderately nerdy. And then this guy here who has no life. And so these two guys. Okay, so that's one way to use it. You'll see this a million times throughout the semester, and so bear it in mind.
Why did you use the complement operator?
Oh, for the destructor? That's just syntax for destructors. Right? Constructors will always have the name of the class. Destructors will have the name, but the tilde.
Okay.
Yeah, just syntax. Okay, and so so we talked about how we can use arrays to allocate, or not arrays, but pointers to hold dynamically allocated arrays. Let's see what happens when we want to deal with things that aren't arrays. And so here, let's see, we have a structure. That's the data type is book. Within a book object, we see that there is a title and an author associated with it. Subsequent to this, we declare a CS nerd. We have a constructor which takes one parameter, in particular a string name. Within this default constructor, I do something like this. I set my book equal to null pointer. Well, let's take a look at the type of my book. My book is a book pointer. So it stores addresses, in particular addresses to books. And so what am I doing with this line of code, with this pointer, book pointer? Yeah, I'm initializing it. And so most of you, if not all of you, would probably, or have probably seen something like this, except with something that looks like this instead. Is this a correct statement? Okay, so for this class and for any code that is being developed past 2013, you're not using this any longer. You're using this. This will only happen if you're working with legacy code. Okay. If you're not working with legacy code, use this always. And the reason being is that this is the compiler understands this and do things like type checking against this. It cannot type check against that. Right? There's a lot of issues that come up with this capital NULL. Okay, so it's not safe, essentially. It can cause a lot of issues in your code. Which is why I'm asserting that you please use this. Otherwise, you might have some bugs that you cannot determine because that hides those bugs from you. Okay, and so initializing my book, and I'm initializing my name if I'm this CS nerd to whatever name I pass into this function. Okay? I have a member function called giveBooks, and it looks like I'm giving books to this CS nerd, in particular string T, string A, title, author. And so what am I doing here? Creating a new book whose address is being stored in my book. And then from that, I can dereference and obtain the member things of books and mutate them accordingly or read them if I like. Right, in this case, I'm changing title to T, author to A. Okay? Clear? And then I have a destructor. Notice, what about this? Well, how is this different from the last example? Yeah, brackets. And so the brackets were important because I was dealing with a dynamically allocated array. In this case, I'm not dealing with an array. I'm just dealing with a single object, right? Just one new book. And so delete here is correspondingly for just a single object itself. So it's just more simple. Okay, but you have to keep that in mind. If you're deleting arrays, you have to use the square brackets. Otherwise, the compiler will just do freaky stuff. Okay, so how do we use this? Let's go ahead and declare a CS nerd, S, whose name is Hal. So this is some motivation, right? Because we're weak and fragile. We can't carry around heavy books, and so we only carry books as we need. And like everyone in here is like 200 pounds, all muscle. The ladies here do CrossFit. It's all right. I like CrossFit, sort of. So, was that like did someone like quietly vomit in their mouth? I heard something. I don't know what it was. So, okay, and so we just want to give them books only when necessary. Okay, and so how do we do that? So here's Hal. Oh, here's a book. Oh, yeah, so here's Hal. Hal has, well, he currently has no books, right, because it's null. Boom. and Hal's name T. So here's Hal. Hal has been constructed. Hal currently has no books. Boom. All right, and so when we, well, in this case, we haven't given Hal any books, and so when we leave scope, we call Hal's destructor, which calls this, and so this would essentially translate to delete null pointer. All right, you guys see that? Because the address stored in my book is null pointer. And so if you use null here, if depending on some compilers, this would break your code if they didn't implement that capital NULL correctly. Here, since this is type checked, the compiler just says, okay, well, you don't have any books, so I don't do anything. Right? So there is actually nothing at null pointer, and so it handles it gracefully. Boom. Okay, and so let's go ahead and give this Hal, or Liz in particular, some books. Liz is reading a calc book by Bill Nye. Bill Nye has not written any calc books, I believe. Do you guys know who Bill Nye is? Yeah. Okay. I was just too quiet. I was scared. So Bill Nye, my hero. I watched his show on Saturdays when I was a kid. And so there's Hal. Construction is the same thing, except with Liz, now not Hal. And then when we call give book, we go into the body of give book. We pass in calc and Bill Nye. This request memory from the operating system. And so the operating system says, okay, here it is. Boom, the address is 45,000. We store that within my book. I can dereference my book and obtain the member title using the arrow operator. Set it to calc. Do the same thing for the author. Set it to Bill Nye. End. Okay, and so when we call the destructor, we delete what address, or the thing at what address? The address that's stored in my book, which is 45,000, right? So what I'm trying to point out is that I'm not deleting my book. I'm deleting the thing that's the address stored in my book, right? So that's an important thing to remember. This does nothing to the pointer. This deletes the address stored in the pointer. So that means delete this thing, essentially, is what that line is saying. Which, in a perfect world, or even in perfect world such as ours, the operating system says, okay, I can go here, get rid of that object, and boom. And notice my book is still here. It still has the value 45,000, right? Because that's just the behavior. It does nothing to my book. It just does something to the thing at the address that's stored in my book. And then we leave scope at some point, and then Liz goes away. She graduates. And so this is one way to use dynamic variables to allocate enough memory for objects. Okay? Pretty basic examples. We're building up. We're building up to more complicated things. Bear with me. And again, single object, we do not need the brackets because it's just one book. Okay, and so we saw how to use new delete to allocate a struct variable. Let's see how all this works out when we have constructors. And so here is a main function in which I declare a Waldo pointer. And it seems like this pointer stores the address of a new Waldo who is being somehow associated with this number 165. And at some point, I delete the Waldo that was created. And so how does this work? So here's the definition for Waldo. Waldo constructor has a weight, and he has bacteria. As we all have bacteria, right? And so when we destruct Waldo, all we're doing here is we're just setting the weight to 0 and the bacteria to, well, I mean, this actually isn't that large relative to bacteria population sizes, but you get the point. And so on. Okay, that's what it is. And so there's Waldo, pointer, or a pointer to a Waldo object. I call a new command, goes to the operating system, request enough data so that we can store a Waldo. that is currently at address 4000. Within this memory location, we have these variables for weight and M bacteria. And now that's not the end of the story, right? What else happens after we have this memory location that's being assigned to PTR? What else must be done? What is invoked? I heard words. That sounded right, but I am deaf. Something, yeah, the constructor, right? And so, I mean, we see it right here, but right now we haven't done that yet because we haven't filled out these variables. And so we call it a constructor, which is fairly new. We haven't really talked about that, right? And so let's go ahead and call the constructor. Here it is, which we set the weight to 165. Boom, boom. And then bacteria to 0, 165. Okay, and so the thing to take away here is that when we use a new command, it calls the constructor for objects, if they have one. Okay, and so this might be different for those of you who are used to using malloc and calloc. Those do not call any constructor. Okay? Have you guys used malloc and calloc in C code? Okay, then never mind. New calls the constructor. It would be a big deal if you use those legacy versions of dynamic allocation. Because some people, if you didn't know that, you might think that the malloc does call a constructor, which it doesn't, right? And so if you don't call a constructor, if you don't call a constructor, you get garbage values. But again, you guys haven't seen that, so don't worry about it. And again, destruction is also a two-part process. Boom. And so it goes into the destructor. It does whatever code there is within the body of the destructor itself. And then boom. OS. We have some dialog where the system deletes the thing at address 4000. In other words, the address that's currently in PTR. And it goes away. All right, so it's the reverse process. Here we create the memory, call it a constructor. Here we call it a destructor, clean up the memory. Okay? And so when we use new to allocate a class instance, this is what happens. All right, memory is allocated, and then the constructor for the object is called. And then when you delete the class, it's the complete opposite. We call it a destructor, and then clean up the memory. Okay, so what? Anyone know? Anyone know why that's important? It's not important. I'm just talking about it. No, we'll see it later. I'm being facetious. So before we talk about the next set of topics, I want to talk a bit about this. But before I talk about this, I want to make sure everyone was comfortable with what we talked about so far. No questions? Okay, and so how many people are familiar with this concept of this? No? Okay, it turns out that within every class instance you create, there is you can think of as a hidden variable called this. And so let me get to a certain point here. Let me add some code here. So suppose I create a wallet object A. I initialize it to something. Let me draw this out so we have some, I mean, there's pictures, but before I get to those pictures, I want to make sure you guys understand the situation without this. This is a minor detail. This is actually a part of a series of slides that I removed. They're actually at the end of the slides, the entire series. So if you're curious about the details of what this is all about, you can look at those there. What I'm going to talk about here is enough for you to understand how to use it. Okay? And so if I declare a wallet A, right? So we go to we compile, we create this wallet A. Let's say it's at address 5,000. And then inside of it, there's two implied member variables, num1s and num5s, whatever they are. So we have num1 and num5s. All right, and so these are whatever they are. And so when I call this code here, A is at address &A, what should I see? 5,000. Oh, yeah, so this is the name, but 5,000, right? Is that clear? Is that not clear to anyone? If it isn't, we'll talk about it. But I'm requesting the address of A, and given that assuming this is the picture associated with this code fragment, then ampersand A should return the address 5,000. All right, is that clear? All right, so this is a review of what that means. And so, not assuming, but given that we have this concept of a this pointer that's created and hidden from you with every single object you instantiate, if I told you that this is a pointer, what does it store, do you believe? A reference to the object or the address to the object you just created, right? And so hidden in here somewhere, there is this variable you can think of, a pointer, a this object, or in this case, a wallet pointer. And within this pointer, when I declare A, it contains the address of itself. Okay, that's what it is. And so how do we use this? Well, one way that they use it is to do this. So I replace that line of code. I mean, you guys understand this, right? This is just chaining assignments. Yeah. All right, so num5s gets 0, and then num1s gets 0. Is that clear? I can replace that with this, and this is identical in every single way. All right, and so the only thing is that what's implied here is that these being member variables to the object, it behaves the way you'd expect in terms of member variables. This is being explicit, saying that this is my nums1, this is my nums5, right? So I'm dereferencing myself to get my own member variables. Okay? This is its usage, and you may or may not have seen this. This is more of a consequence of the language. This is how they facilitate object-oriented programming on top of C, is through this pointer. It's just hidden from you through the language itself. And again, if you want the details of why this is, take a look at the slides at the end of the slide series. But I'm not going to test you on it, but you will see this.
Is there any difference with scope and comments?
Not at all, right? So this is, let me be a little bit careful. What do you mean by that? So there's no change in anything.
That's what I was asking. Where you can access it or
No, so I mean, this is still a member variable. It's just I'm doing it a different way. It's kind of like, so doing it this way is kind of like, yeah, I'm accessing my own arm in this case, right? So if I'm an object with an arm, this is my arm. This is saying like, I want to call myself, like have an extra, some out-of-body experience to dereference my arm and then manipulate my arm. It's weird. But anyways, so this is a address to myself. If I'm at address 5,000, that means 5,000 dereference grab nums1, but that's just myself if I'm this wallet. And there's various situations. Some companies use this to explicitly show that you're trying to access member variables, right? It's pretty explicit here, right? I see this and I know for a fact that I'm dealing with this object's nums1 member variable. Whereas, if I brought it back to this, if I didn't tell you that this was a member variable for this object, it's not clear because I don't give you the rest of the code, right? And so it might be ambiguous. It might even be worse if I passed in to this function. Let me change it. Suppose this init function, so wallet init void. Suppose it was defined as, it's a wallet object, init. If I passed into this int num1s, and I have a member variable called num1s, I can do this. There's nothing wrong with it. So how do I make this assignment in this case? I mean, if I try to do num1s equals num1s, which num1s do I mean? Right? And so, well, I mean, the fix is not to use the same identifiers, right? But if for whatever reason you want to use the same identifiers, you would use this to refer to the one that refers to your member variable. Yeah.
I feel like I've seen this a lot in constructors. Like,
yeah.
Use the same member variables and they just use this.
Yeah, yeah. Well, I mean, so there's two fixes here. Not to use the same identifiers, which is what we've been doing or what we've been practicing, because you guys haven't seen this. But alternatively, I want to make clear that one of these is the parameter and the other is the member variable. I mean, I kind of gave it away, but which is which? The right-hand side is whom? Is coming in, and then the left-hand side is the member object, and so this is the guy that is mine, and so I make it explicit by doing this. A lot of this is. And so this is you'll see this in code, right? So just be aware of it. But of course, for us, I am of the belief of, well, I use a convention, I just use different identifier names, right? So I don't change this to something else. I don't like using this. It's just, I don't know, it seems like it bloats my code up. But the advantage is that it makes it explicit what you're dealing with, right? So there's no ambiguity with regards to what nums1 is. It has to be a member variable, otherwise you cannot do this. But anyways, so what? So let me go through this code. So I'm going to add the cout statement in which I send out what is currently stored in this. You can think of it as a pointer. And so boom, I declare wallet A, address 1000. I initialize everything to 0. Boom, and then I execute this statement. And so given this example, I'm sorry, I kind of messed up on the board. This should return what? 1000, because that's where this is currently residing in memory. Boom. And then we get down to this line of code, and it does the same thing because that's the address of the object. Yeah?
I always thought like this was used for, my understanding is that you use it in functions when you're trying to like make your function work on any type of object that goes into the function, right? Like it allows you to access the member variables of an object that goes into it without identifying it by its name.
You cannot use this and not have it mean the current object. It cannot refer to any other object.
It's like the current object that's being passed in at runtime, right?
I don't see the use case, and I think that would not work, right? So if I'm passing in any bit of code that I'm passing an object into, so I can't refer to this outside of this class for this instance of it, right? So I think right away that sort of invalidates what you're trying to do. This is private in the extreme. This cannot be accessed outside the class, only within the class itself.
I just thought it allowed you to like refer to objects, because you know how you're like creating like lots of objects at runtime, like
Okay.
you know how like we like will manually make them like new A1 cat, right? Or,
Sure.
I thought that like at least with my Java experience, that like
Yeah.
that
So
line-
detach away Java. Yeah, when we start talking about memory, you can no longer talk about Java in any way at all.
Right, because I think we used it to like refer to like the current object at runtime.
Yeah, I mean, I think convention actually has you should use super in those cases, but again, this is not a Java class. But so let me say this about this. So if you learn other languages, that's great. But when we start getting in terms of talking about these mechanical details or underneath the covers, underneath the hood of the language, you have to detach away from those other languages because they do things differently than C++, Java in particular. So yeah, so when you see the words like this and even private and static, you can't think in the same way. So in this case, for C++, this is just a pointer that stores the address of the object you just created by using the new command, or even compile time objects as well. Okay. We went on a whole bunch of tangents. I want to make sure people understand. This is just a pointer. Okay. Is that easy enough to remember? Okay.
So is it accurate to say that like the primary function of using this in functions involving your classes to make it really, really clear that you're accessing member variables, not overloading?
That's one way you can use it. We're going to see it again when we do things like overloading the assignment operator, because there's something that we need to do there that we cannot do without this pointer. That's where I'm moving towards. But I'm just saying, I'm providing this here as a reason why people use this keyword in their classes. But I don't think it's the primary reason, because you can live without it, right? And I do live without it, except for when I overload assignment operators. Okay, and so that's that. And so let's talk about why we should care about, well, pretty much everything we just talked about and the consequences of all these things. But I'm wondering, we did go on a bunch of tangents. I am doing a context switch. And so I want to, would it be useful for you to rest your brains for a bit before I get into copy construction? Okay, I see enough nods that I will say break time. 1, 2, 3. Oh, I'm the only one. You guys don't play sports? Come on. 20 minutes, is that sufficient?